Hello, hi, good morning, my dear students. Again, we are continuing the first chapter, that is some basic concepts of chemistry. In the last class, we have observed that we are beginning to study the laws of chemical combination. So, chemical combination is containing 5 laws. The first one is law of conservation of mass. It says that can either be mass, matter can either be created, not destroyed. Second one says that the masses of the element, it may be a naturally or it may be a synthetically, but the composition remains as it is, means mass will be the same. So second law, it is called as law of definite proportion, and that second law is also called as law of definite composition. You should remember it's having two names, definite proportion and also definite composition, both are same. And let's begin the third one. So this is the law of multiple proportion. So law of multiple proportion is one of the law. As the name says, this theory explains about the multiplication of the elements. Multiplication of the elements. How means? This law says that when one of the element, mass of the one element combines with the fixed mass of another element, it will be always in a fixed ratio. What it means? Suddenly by observing the definition of statement, you may feel you can't able to understand, but by theoretical some examples you can able to understand the multiple proportion law. So here hydrogen combines with the oxygen, it gives water molecule. Can you see here by balance the one H is 2, here also oxygen is 2, it is 1. Therefore we will put oxygen 2 and hydrogen is also 4, 7. As reading the bridge course, the mass of the hydrogen here, each of the mass is having 4. I mean one of the hydrogen is having the mass 1, total number of hydrogen is 4. Therefore it is 4 gram. And this is, each of the oxygen is having 16. Atomic mass of oxygen is 16. Hence total oxygens are 2. 16 2s are 32 gram. Similarly, each of the water, hydrogen is 2, oxygen is 1. So it is having 2 H2O. Each oxygen is having actually 18 gram. Total number of waters are 2. So it means that it is 18 2s are 36 gram. How means it is a combination of 4 gram plus 32. 4 plus 32 is 36 gram. So 1 mole of the water containing 18. Here 2 moles of water containing 36 gram. So the theory is going to explain that water is always having the molecular formula of water is having the H2O. 2 moles of hydrogen and 1 mole of oxygen is present. But the mass of the content, can you see here, hydrogens are 2 and oxygen is 1. 2 mole, 1 mole. If nothing is there, means it is 1 mole. The same compound, if we want to put the 36, I would like to make it double. Means if I want to write the 4H2O, then I need to put the number of oxygens are totally 2 moles of oxygen. Then hydrogen becomes 4 mole. Means I simply multiply the whole reaction. 2 mole of oxygen is converted as 4, 1 mole is converted as 2 mole. Similarly, 2 mole of oxygen, water is converted as 4 mole. So it means that as the number of moles are double, we are getting the product also double. So 2H2 is converted as 4H2. But you have to look here. Here also the number of oxygens are in the ratio 4. Can you see hydrogens are 4? Oxygen is 2. Oxygen is 2. So on dividing the whole term by 2 1 2 2 again the ratio will be 2:1. Means always water is having, not only water, any of the compound, if 1 mole of the or any one of the element with the same mass, it reacts with the exact or fixed molecular mass of the another oxygen or another compound. It's going to give a compound. That compound is having the fixed ratios or fixed multiples. So if I want to say the water is nothing but, it doesn't mean that 2 moles and 1 mole oxygen is necessary. We may take, instead of 2 we can take the as 4, but we can't take the 3 because we have to multiply this proportion by the whole number. 2, instead of taking 2 moles we can take 4 moles, or we can take 6 moles. Means The least is oxygen. Oxygen, if I take 1 mole, hydrogen should need 2 mole. If I take oxygen 2 mole, the hydrogen needs 4 mole. If I take oxygen 3 moles, then I need to take hydrogen 6 moles. Means we have to maintain the ratio. Along with that, if we want to form this product in a different way, the multiple proportion should be the whole number. 1 if we have taken 2, corresponding ratio should be maintained. This is said by the law of multiple proportion. This theory states that the law of multiple proportion states that when an element of a given mass combines with the fixed mass of another element, it is having the multiple of whole number, and the ratio should remain the same. So do you understand? So this is how the example based you can able to understand, and I am sending the notes. Based on that you can write on that one. And they are not asking you the examples only for your convenience. Okay. Coming to the next one. The fourth one is Gay-Lussac's law. So in the fourth one, Gay-Lussac's law of gaseous volume is going to express the same concept of the previous one, but he is explaining the theory on the basis of gaseous volume. How means, if hydrogens combine with the oxygen, it is going to be the water molecule, but here you should not forget that hydrogens and water molecules always 2 mole, whereas oxygen is 1 mole. So it means that when you are taken the hydrogen, gaseous hydrogen of volume 100 milliliter, and oxygen here how much it should be in your mind. If the hydrogen is 2 mole and it is 1 mole, means half of this one is 50 milliliter. When 100 milliliter of hydrogen combines with the 50 milliliter of oxygen, can you guess how many moles, how many milliliter of water we get? On the basis we have to look at the moles. Here it is 2 mole, here it is 1 mole, again it is here 2 mole. So 2 mole we have taken as 100 milliliter. Similarly, we are going to get the 100 milliliter of water. How we are expressing means to justify how much amount of the product is obtained on the basis of reactant, it is possible only on the basis of balanced chemical reaction. So that's why sometimes they are not giving you the reaction. If they have given, they will give only sentence hydrogen plus oxygen reduce water. At that time in your mind you have to calculate that hydrogen is 2 mole and it's 1 mole, whereas water is a 2 mole. So if 1 mole you have taken as 50 milliliter, to the 2 mole you have to take the double of that one, 100 milliliter, and here also 2 mole is nothing but 100 milliliter. So what he is telling the Gay-Lussac's law of gaseous volume, he says that when a chemical reaction or the gaseous product are combined or produced, they are going to combine a ratio, or they are going to combine a reactant in such a way that a fixed volume of the average will be considered. It is on the basis of the balanced chemical reactions. Are you getting this point? Gay-Lussac's law, the volume of the gas is based on the molecules. So this is about the Gay-Lussac's law of gaseous volume. So this is the last one, and the next one is the last one. So this is very simple concept, that is Avogadro's law. In the last law of combination reactions, the fifth one is Avogadro's law. So Avogadro's laws you are going to be very much familiar in the further education, but here they are giving some statements about the first one what the Avogadro, the scientist, stated. So here Avogadro's law is nothing but he is going to say that the equal volume of the gases, in that these two are the equal, the volume is same. The equal volume of the gases, here the gas may be anything, hydrogen or oxygen, or it may be anything. If the volume is same and if they maintain the constant or same temperature and pressure, should be same. When the equal volume of the gases with the constant means same, unvariable, not changeable of temperature and pressure. Temperature and pressure should be same. At that condition, the volume of the different gases are having the same number of atoms or the molecules. So it means that the equal volume of the gases at a constant or same temperature and pressure, they are having the same number of moles of atoms, number of moles of atoms. Means atoms or the molecules will be same in the different gases also. When means they should have the same space, the container should have the same volume, and temperature and pressure should be constant. Means both of the volume, the temperature and pressure should be same. At that time, it's understood the number of atoms present in. It may be a hydrogen or it may be a nitrogen, oxygen, anything. If the hydrogens of the same equal, they are having the equal volume and temperature is same, then how many atoms of hydrogens are there? Same amount, same number of oxygens atom will be there. If it is another gaseous compound with the same volume and temperature and pressure is same, at that condition also number of atoms or the molecule remains same. So that is the statement of Avogadro's law. Avogadro's law states that at equal volume by constant temperature and pressure, the number of atoms or molecules remains same or constant. So this is about the Avogadro's law, and actually it is having some value, but here they have not mentioned. You are come to know that in next coming classes. So coming to the next, so in this laws of chemical combination, among these five, any one will be asked in your annual exam. Definitely one will come. So it may be for 1 mark. If Avogadro's laws asked, means it will be for 1 mark. If another second or third one asked, means sometime they will ask you 2 marks, or probability is capable of only 1 mark. So you should remember the laws of all the five. Okay. So the next very important theory is, it will be asked for 3 marks and it's most important. The name of the theory is Dalton's atomic theory. Explain the Dalton's atomic theory means you have to write these 4 terms, and sometimes they will ask you write the postulates of Dalton's atomic theory. Postulates means siddhanta, terms and conditions. So postulates are nothing but you have to write this code or explain the Dalton's atomic theory means you have to explain this one, or simply they will give you discuss the Dalton's atomic theory means you have to explain this one. So it will be asked for 3 marks. So let's begin. The Dalton's is the name of the scientist. He is going to explain first time what will be the atoms combined, how it forms as a molecule, and he is saying some of the terminal points. What means assumption? He is doing some assumptions. Assumptions are nothing but they are stated as postulates. Assumptions of Dalton's atomic theory is nothing but postulates. So here, look at the first one. He has given some of the postulates. The very first postulate is matter consists of indivisible atoms. So matter consists of indivisible atoms. So here, so if we can take any of the example, if I want to say that this is the choppies. So choppies, or you can take the example of duster. This duster is a matter. It is containing, so it is made up of the atoms, many number of different atoms. But first condition is the matter consists of indivisible atoms. Means if I am looking at the duster is having some different atoms, same atoms. Whereas if I look at this container, plastic choppies box, so it is a paper. It is made up of different atoms. Means the atoms present in this paper is identical, whereas the atoms present in this wood or this duster is identical, whereas the atoms present in this choppies, this is also identical. So it means that the atoms present in this one is identical. Identical is nothing but the atoms which are present in this molecule, they are similar, but different atom is present in this container, this matter, and similarly another different compound is present in here. So overall the whole atoms present in this one is same, and the whole atoms present in this choppies is same. So that's why he is saying that matter consists of indivisible atoms. Indivisible is nothing but some of the atoms, it may have 1 or 2, but overall the matter is consist of same kind of the atoms, where another matter containing the different atoms. Are you getting my point? So next one is, it is obviously, if you are taking as water, the water is nothing but it's having H2O. If you are thinking that sugar is having the sucrose values, C6H12O6. Always the sugar is having different, and it may be a different kind or different place of the sugar. And salt is nothing but it is a element. Salt is always having NaCl only. So that NaCl will be always having the individual atoms, and sugar is having individual atoms. Water is having individual, any of the matter is having individual same, but another matter is having different its own individual atoms. Are you getting this one? So here matter consists of individual atoms. First one. Second one is, identical atoms have identical mass. So identical atoms are nothing but whenever we are taking the hydrogen is having mass is 1. Whenever, wherever, with any of the reactant, in any of the compound, in any of the molecule, if you are taking as a hydrogen, it may be present in molecule, or it may be present in any of the compound, or anywhere individually, but hydrogen, a single H is always having the molecular mass 1. So it means that identical atoms means same of the atoms. If you are taking oxygen wherever it is having the identical mass. The mass of the oxygen remains same. It may be in individual, or it may be in any other compounds. So similarly, the different atoms have the different masses. So different atoms are nothing but, if we are talking about the hydrogen, everywhere hydrogen is same. If you are taking on the oxygen is same, but comparing to the hydrogen and oxygen, these two are the different, and these two are having the different masses. Are you getting this one? So identical atoms are having the identical masses, and different atoms are having different masses. It is obvious things only. And coming to the third point, compounds forms by the different atoms with a fixed ratio. Compounds are nothing but, if I am talking about the hydrogen, single hydrogen is an element, or it is atom. So one hydrogen combines with another oxygen. So oxygen is also element, means it is individual. So hydrogen and oxygen. Hydrogen is also element, oxygen is also element. When these two are combined, they are going to form as a water. So water, we are not calling that as an element, it's a compound. Why? Because it is combined by the two atoms, means one is hydrogen, another one is oxygen. Therefore hydrogen and oxygen together, it's going to form a compound. So here, whenever the compound is forming, they are combining by the different atoms with a fixed ratio. Fixed ratio is nothing but, commonly you can take one example. Water, it's having H2O. H always 2, oxygen is 1. H2O, the ratio remains same. Similarly, ammonia, the formula of ammonia is NH3. Whenever you are taking the ammonia, NH3, number of hydrogen is 1. Hydrogen is 3. NH3, 1:3. It is fixed. Whenever we are talking about the benzene, C6H6, carbon should be 6, hydrogen should be 6. So it is fixed ratio. Similarly, carbon dioxide, CO2, carbon is 1, oxygen is 2. So it means whenever the compound is formed by the different atoms, they should maintain the fixed ratio. Okay. And in the fourth one, when the reaction is carried out, reactant to the product is formed, means reactant to the product is formed, means it is a synthesis of another compound. Synthesis of another compound, at that time we are reorganizing the compound. Reorganization. It means when the two compounds are combined, these are the two reactant together, it is compound combined, means it's going to give the another product, that is, it will be different. So if it is different, means it doesn't mean that we are not synthesized the new thing. It doesn't mean that we are not created the new material. It doesn't mean that we are not created the new mass. No, nothing. So simply we are reorganizing the compounds. Reorganization means we are simply arranging from one place to the another place, from one state to the another state, from one structure to the another structure. Like that we are converting. Reactant to the product is not, means that we are not creating that one. We are not making that, destroying the reactants. So it's only the conversion, it's only the rearrangement that is called as reorganization. Whenever the reaction is taken place from reactant to the product. So it means we are preparing the new thing. New product is formed. It means the formed product is always is nothing but it's a reorganization. This is according to the Dalton's atomic theory. He is saying that it is a reorganization. We are not creating that one. Simply we are converting that reorganization. It means that whichever the product is formed, it is not possible. These are neither be created nor destroyed. So whichever the compounds we are formed means reactant to the from reactant we are forwarded as a product. So we are not destroying the reactant. We are not generating the product. It's not possible. Simply we are rearranging. The reactant is converted as product. It's a reorganization. It's nothing but rearrangement. According to this theory is only about the Dalton's atomic theory. So in the higher means in the 9th standard you have studied about the same things. So where you have studied about the slightly different words and here the words are different. So I think somewhere you are familiar with the Dalton's atomic theory. So I hope you can able to understand this one. These 4 terms you have to write if they ask to explain the Dalton's atomic theory, and it will be the important for your anyone's exam also. And if we arrange some example, and that time also it's important, and it's for 3 months. Okay. So in the next theory, atomic and molecular mass. So molecular mass is nothing but the determination of mass of the compound. It's called as molecular mass. Whereas atomic mass is nothing but it's a single indivisible atom's mass. Atoms are nothing but same: hydrogen, oxygen, nitrogen, calcium. The indivisible atom's mass is the atomic mass. Here we are going to discuss atomic and molecular mass. But the first term in this heading is atomic mass. The subheading is atomic mass. So atomic mass is nothing but you are familiar with hydrogen is having 1 mass, oxygen is 16, carbon is 12. That we are already familiar. But in the initial point, how they are determined this atomic mass means. So according to their before in the 19th century, beginning of 19th century, we were not having the instrument to calculate or take the masses of atoms, because atoms is very less, it is negligible. At that time they are decided to take the masses using the least number of the atoms. So hydrogen is being a very lightest atom, so hydrogen they are considered as 1. With respect to that they are named as 2, 3, 4, 5 like that. So nowadays we are having different terms, we are having very extraordinary instruments to measure. So therefore, based on that, how we have calculated means nowadays we are calculating the atomic mass unit on the basis of AMU, atomic mass unit. AMU is nothing but atomic mass unit. What is atomic mass unit? Atomic mass unit is nothing but we are determining the mass of all the elements by comparing with the carbon atom. Carbon is considered as a standard atom. So carbon is having some isotopes. Isotope is nothing but having the same atomic number but a different mass is called as isotope. So atomic mass unit is nothing but it is the 1/12 the mass of carbon 12. So it is, what is atomic mass unit means? It is the 1/12 the mass of carbon 12. Carbon is having the isotopes carbon 12, carbon 13, carbon 14. There are 3 types of the isotopes are there. So in among these 3, the carbon 12 is considered as a standard. The mass of that carbon 12, the mass of this carbon 12, its 1/12 division is itself is called as atomic mass unit. So atomic mass unit is the 1/12 the mass of carbon 12 is called as atomic mass unit. What is AMU? They will ask for 1 month. So AMU is nothing but atomic mass unit, and you have to define it is the 1/12 the mass sentence. So what is the AMU? How it can be determined means, commonly 1 AMU is having the value 1.66056 into 10 raised to -24. 1 AMU, commonly any of the 1 AMU. So we know that mass of 1 hydrogen atom, before it is telling about initially actual mass of 1 hydrogen atom is 1.6736 into 10 raised to. So here the mass of 1 atom of hydrogen is this one. So in terms of AMU, in terms of atomic mass unit, the mass of the hydrogen can be calculated by dividing the mass of the hydrogen by 1 AMU. So at that time we are going to get 1.0078 AMU. So 1.0078 is nearly equal to 1.008 AMU. Nowadays we are writing that atomic mass unit in the short form of U, whereas U is the unified mass. U is nothing but unified mass. Atomic mass unit is nothing but we are representing that symbolically U. U is nothing but unified mass. So this is important. They will ask you only about the atomic mass. What is atomic mass? This is important. And in the next class we will see about the continuation of this one. Means average atomic mass and molecular mass. These are very simple and you are already familiar about these concepts. And probably next videos we are going to end this chapter. So any doubts, feel free to ask. And if you are having